So next one is by Indira Rani from NCMRWF, not ECMRWF.
My talk is impact of MODIS sounded data assimilation. That the case we took is the maiden snowfall over Jammu and Kashmir during December 2010. This work was done at SIMS, that Cooperative Institute of Meteorological Satellite Studies at Space Science and Engineering Center, University of Wisconsin, under ISRO SSCC project. Under this project, this is actually INSAT 3D project, under ISRO SSCC project, 4 projects were there. One is sounded data retrieval, one is CMV retrieval, one other one visualization, and next one the assimilation of retrieved sounded data. So the model we used is the DBGRASS, that is the direct broadcast SIMS regional assimilation system. This is direct broadcast because we can install this model where we have the direct broadcast MODIS or AIS antenna. These are the some configuration of DBGRASS. Domain center we choose as Delhi, and horizontal resolution is around 48 km. Vertically we have 38 levels, and topography 2 minutes USGS data. Then the importance of this model is, in addition to different meteorological parameters, we can generate synthetic water vapor and IR satellite images. So ancillary data required to run this model is the global NOVA 24 km daily snow cover file, then global surface observation, NSUB daily 0.5 degrees sea surface temperature, MODIS sounded data that we use cloud top pressure and effective cloud amount, and the total precipitable water retrieved from MODIS to correct the cloud and cloud top pressure and effective cloud amount in the model. Then NSUB global forecast system, half degree forecast file as the lateral boundary condition. Then this is the step towards the assimilation of INSAT 3D sounded data. In MODIS we are getting the total precipitable water, total column precipitable water, but in INSAT 3D we are getting 3 layer precipitable water. So once INSAT 3D is through, that SAC has to generate that means one transmissive file, and we can do the assimilation of INSAT 3D data also. This is the assimilation window. We used to start T-12 hours. Then whenever we are getting some satellite passes, we used to assimilate that one. A 12-hour spin-up forecast is used to adjust the water vapor and cloud. Satellite information is inserted at the mid-time of each individual satellite scan. And this water vapor, cloud and precipitation mixing ratio from the 12-hour spin-up are merged with 6-hour forecast, GFS winds and temperature from the previous GFS run. This merge is conducted all the 25 pressure levels. And our case is the first major snowfall over Jammu and Kashmir during December 2010. The northern part of India, Jammu and Kashmir, experienced the first snowfall of 2010-11 winter on Thursday, that is 30th December 2010. Snow which began falling on Wednesday 29 December accumulated in sizable amounts throughout the valley, and it caused considerable disruption and power and transportation. India Meteorological Department, they already predicted the heavy snowfall on the coming days of New Year and including the New Year Eve. IMD has had also given the forecast of the arrival of a western disturbance. Actually this western disturbance caused the snowfall over Himalaya and the heavy rainfall over the valleys. This is the impact of MODIS sounder product assimilation during spin-up. Here spin-up means that is the data assimilation period. You can see the first one is the with MODIS, and that one is without MODIS. This is the corresponding precipitable water. Then you can see the MODIS passes. So here we have one pass, second, third, fourth. So total we have 5 passes. So during data assimilation we adjusted the analysis so that this one is the MODIS with MODIS assimilation, this is the without MODIS, and with MODIS this is the corresponding precipitable water. This is the corresponding Kalpana image. So you can see with MODIS assimilation here, so it is not visible, here we could capture the cloud whatever initially in the observation. So how realistically DBGRASS captured the western disturbance characteristics. This is the low level moisture incursion. So that asymptotic convergence of low level wind from Arabian Sea and Bay of Bengal, and it in turn means pump the moisture to the low pressure area formed over this region. So the shifting of seasonal anticyclone eastward of Bay of Bengal and the convergence of streamlines from Arabian Sea and Bay of Bengal caused the incursion of moisture into the low pressure system formed over Pakistan and south of Jammu and Kashmir, and this in turn strengthened the low pressure system. So this is the influence of western disturbance. It's the 850 HPA geopotential and horizontal wind. You can see that here we have the low pressure system. This is 24-hour simulation, this is the 36-hour simulation, and we are taking the NSEP analysis as our observation. So 24-hour simulation and 36-hour simulation, DBGRAS could capture the low pressure system over south of Jammu and Kashmir. This is the 700 HPA level. So you can see the western disturbance which is coming, it is splitting into two. Here one around the low pressure system and one north of that low pressure system. Again that 500 HPA also we can see the influence of western disturbance. Again it is splitting into two around low pressure system, and further moving northward means eastward it is converging. So again in 300 HPA also we can see. So from 850 to 300 HPA we can see the influence of western disturbance. So that DBGRAS could capture this features of western disturbance with the assimilation of MODIS sounder products. So DBGRAS accumulated precipitation and TRMM data. This is the without MODIS and with MODIS, and this is the observation. So even though DBGRAS could not capture the pattern of precipitation, but with MODIS assimilation it could capture the maximum value here. Even though there is an overall agreement in the precipitation pattern simulated by the model with TRMM observation, the model simulation showed widespread precipitation southward. Thank you.
Okay. You've shown a lot of these contour plots and all that. See, mathematically you use some filter, right? Now, I am at a loss to see no plot of probability distribution of the variables, how they vary with time. How do you compare it with normal plots and other things? None of the mathematical or the gains, how they vary, which I like very much. No, but as you go through, gain is part of your thing, and the state variables, whatever is the distribution, is a part of your program, is it not? There is output, right? Why you don't show any of those things? Because that will give insight to people. But here, you can plot something. We accept your result. It is trustworthy. But if somebody wants, they can also plot something which is not, which matches with the observation, and then get away with it. You see.
Just to clarify for myself, NSEP analysis is actually reanalysis, right? I mean, so there is analysis and then there is reanalysis. Okay.